All right, so the big slide. How long is it? See, because it's an American thing, so it's in, I went online, I found the dimensions that they used, 200 feet. So if it's going to be in feet, we could convert feet if we want, but it's just as easy to say that gravity is 32 feet per second squared. It's the equivalent to 9.8. Okay? And so what if it's frictionless? The acceleration is g sine theta. So that's going to be 32 times the sine of 24. Somebody help me out?
13.02.
13.02. Okay, so if that's acceleration, we want to know how fast is he going at the end. So Vf squared equals Vi squared plus 2Ag. Now, what's the initial velocity? 0. 2 times 13.02. It's 200 feet though, right?
It's not a big deal, Mr. Brown.
That's big, right? Okay, so that's 2 times 13.02 times 200. Take the square root. And I get 72.2 feet per second. That's pretty fast, isn't it?
No.
I don't know how to convert that to anything, but I know that it's fast. 72 feet per second. Okay, now if we want to know the range, right, the horizontal distance, I got to know, that's how fast it's going, right? But now I've got to project it. Now I've got the second part of my my problem here. I've got a ramp angle here of 30 degrees, right? We're going to assume that he's going the same speed at the top here, because he's coming down this big one, right? And then going up. Now, is he actually going to go this, like at the bottom of this ramp, he's going 72. Is he going to be going 72 at the top? No, in fact, he's going to do what? He's going to slow down, right? But we don't know this distance here. We're going to just ignore that fact for the time being. But he would actually slow down. And you could figure that out too, right? You could figure out the acceleration, deceleration. If you knew the distance, you could figure out how much it slows down. All right, so we need to break it into components here. The horizontal component is going to be 72 cos 30. 72 cos 30. $62.4. The vertical is going to be 72 sine 30, which is 36. Now, which one of those two things determines how far it goes? The horizontal, right? However, some might argue, well, the vertical does, because that's the one that determines how long you're in the air, which helps you go farther, right? So what we really need to do is we need now to figure out how long it's going to be in the air. So, in a sense, I'm doing this. I'm projecting off a cliff that is 12 feet high at an angle of 30 degrees, and those are my components, right? So I need to know the time of fall. So what's my overall displacement going to be? I'm going to start here, I'm going to go and then land down here. My overall displacement is minus 12. And that is equal to VIT plus 1/2 AT squared. The overall displacement is minus 12 from there to there. So I've got minus 12. What's my VI in this one? Is it 72, is it 62, or is it 36? It's displacement, it's not distance, Carly. So it's here, that's a good question, right? It's there, and then it's there. So final minus initial, it's 12 below where it started, and it doesn't matter how high it went. Okay? Now, when you see the acceleration, when I plug this next part in, I think you'll get it better, okay? So which VI do I use? Do I use the 72, the 62, or the 36? Because we're talking about it going up and down. Time of, well, we are, but we need to find the time first, right? And we're talking about, it's the vertical bit that determines how long it's in the air, right? And the horizontal just sort of tags along for the ride. So it's 36t plus 1/2 of minus 32t squared. Make sure you use 32, not 9.8. Now you'll notice the 36 is positive. This one is negative, and this is Carly why it works, because this is up, so it's taking into account the up and then the back down, right? This is what it would be, maybe I'm not. This is the acceleration part, right? This is the part that brings it down, this is the part that takes it up. And so when you combine them together, you get the up down. Put it that. So you're probably not going to like this, but this is going to end up with 0 equals, half of 32 is 16 minus 16t squared plus 36t plus 12. And guess what we just got?
Quadratic.
Any cheers?
Yay.
Yeah? Yeah, not so much, eh? All right. So minus b, that's going to be minus 36 plus or minus the square root of b squared is going to be 36 squared minus 4 times a is minus 16 times c is 12. All over 2 times minus 16. I prefer to just graph it on my calculator and find the zeros. (36) minus 4 times minus 16 times 12 square root 45.4 all over minus 32. Now, quite often in these situations, one of the times is going to be negative, because in reality, you're trying to find the zeros here, if you think about it mathematically, and it's not obviously going to be this one, right? So which one of the positive or negative is going to make this a negative time? Minus 36 minus 45 all over minus 32 is going to result in a positive number, right? Because I got a negative on the bottom. If I went minus 36 and then I added 45, I'm going to have positive on the top, negative on the bottom. That's going to give me that negative one. So it's going to have to be the subtraction one. If you want to do both and then just check, one of them is going to be negative. I know right away that by looking at it that it's going to be the subtraction one that's going to work. So minus 36, subtract 45.4, and then divide that by minus 32, gives me 2.5 seconds. Does that seem kind of right? 2.5 seconds?
Sure.
Yeah, that's right.
Seems like ballparkish, right?
Oh, yeah.
I mean, the other thing to account for too is that these guys, they did it. Do I still have the video
Is
up?
this how long he's in the air or how long he's
That's how he's in the air, yeah.
4 times?
Yeah. Yeah. He's going pretty high, right? Okay, so now how far does he go? V bar equals d over t. He's traveling horizontally. He's traveling 62.4. What's his distance if he goes that fast for 2.5 seconds? 158.7 feet. That's like 50 yards. Think about the golf course, 50 yards. It's pretty far. And that's assuming no friction, right? That's assuming no friction coming down the ramp.
Can we watch a physics video?
It's assuming no friction up the ramp. It's assuming that he doesn't slow down up the ramp, and it assumes no air friction either.
Go to YouTube. It's both.